Few of the creatures living on Earth today can claim to have outlived the dinosaurs. Among them are turtles, close relatives of the prehistoric reptiles that vanished long ago. Their ancestors first appeared at the dawn of the dinosaur era. Thanks to their unique anatomy and lifestyle, turtles have thrived right up to the present day. Today, we'll explore how turtles developed their distinctive shells and why they were able to survive multiple mass extinctions. The earliest animals that can be classified as turtles appeared around 220 million years ago, near the end of the Triassic period. Scientists still don't have a definitive explanation for why their skeletons evolved in such a way, nor do they know exactly which creatures were their direct ancestors. The modern turtle skeleton is quite complex. Their shell is made up of two main parts: the upper shell, called the carapace, and the lower shell, known as the plastron. The carapace is supported by flat, nearly straight ribs. These ribs are covered on top and along the sides by hardened, keratinized skin plates, which evolved from scales. The shape and size of these plates don't exactly match the underlying bone structure and vary widely between turtle species. The plates running along the middle of the shell, covering the spine, rest on flattened projections of the vertebrae. In most species, this central part of the shell consists of 8 large vertebrae and 8 pairs of ribs attached to them. Near the head, there is an occipital plate, while near the tail you'll find 1 or 2 coccygeal plates and a tail plate. Along the edges of the shell are the marginal plates, usually numbering 11 in total. The central plates of the carapace connect to the plastron, the belly shield, which is made up of 4 pairs of large, flat plates. Between the 2 front plates lies a round bone called the enoplastron. Some turtles have a special mechanism that allows them to completely close their plastron. It's believed this adaptation arose because the ancestors of modern turtles lived in environments with extensive wetlands. Originally, these reptiles inhabited water bodies like rivers and lakes, but after the disappearance of the ancient Tethys Ocean, these habitats gradually shrank and became swampy. A flat, broad body allowed turtles to move comfortably through swampy terrain, though it significantly slowed their pace. It was during this time that turtles developed their distinctive armor. Over time, many species evolved to have shells that were much simpler and lighter. For example, modern sea turtles have abandoned the solid bony covering on both their backs and bellies. Instead, their limbs transformed into flippers through evolution, enabling them to swim at speeds of up to 25 miles per hour. The neck of almost every turtle consists of 8 vertebrae of varying sizes. Many turtles have highly flexible necks that can fold nearly in half, allowing them to retract their heads beneath their shells for protection. For a long time, it was believed that the ancestor of all modern turtles was Progonocales, numerous skeletons of which have been found in what is now Germany. Different species of Progonocales also lived in Greenland, Argentina, and Thailand. This wide geographic range during the late Triassic suggests that this turtle was widespread across the ancient supercontinent Laurasia. Progonocales measured about 3 feet in length and was herbivorous. It already had a fully developed shell remarkably similar to those of modern turtles. However, its ribs were not yet as broad but featured additional bony connections. This reptile had no teeth. Instead, its head ended in a beak-like structure made of hardened jaws. Small teeth were present on the roof of its mouth, though. It's believed that the loss of normal teeth occurred after the carnivorous ancestors of Progonocales shifted to a plant-based diet. Additionally, it had a tail with a distinctive club-like thickening at the end. This feature was likely used as a defense mechanism against predators, but it disappeared in later turtles as it became unnecessary. The first remains were discovered in Germany in the late 19th century, and for a long time, Progonocales was considered the oldest known turtle species. None of the 300 species of turtles living on Earth today are direct descendants of Progonocales. In 2008, a new species called Adaptations was discovered. This aquatic reptile lived in the seas and rivers of what is now China roughly 200 million years ago. Unlike Progonocales, Adaptations still had normal teeth and possessed only the plastron, the lower part of the shell. Their carapace was only rudimentary, but by the time Progonocales appeared about 10 million years later, the protective armor on the back was fully developed. However, there are alternative scientific theories regarding the absence of an upper shell in Adaptations. Some suggest that their ancestors adapted to a fully aquatic lifestyle and, much like modern sea turtles, shed the heavy bony carapace to gain greater speed and maneuverability. Another theory proposes that their carapace was made of softer tissues, which would explain why no fossilized remains of it have survived to the present day. So far, no fossils have been found to definitively support either hypothesis. Scientists have been searching for the extinct ancestors of turtles since the late 19th century. Over time, various prehistoric creatures from the Permian and Triassic periods have been proposed as candidates. Among the earliest considered ancestors of modern turtles were the Sauropterygia. This is a superorder of lizards that lived entirely in aquatic environments. Among them, Gymnota or Kynodus can be considered especially close to turtles in appearance. Kynodus inhabited what is now Germany at the dawn of the dinosaur era. It had a distinctly pronounced plastron and a broad, flattened carapace on its back. The shell of this reptile was made up of more plates than that of modern turtles. On each side of its mouth, it had one prominent tooth. The rest of its teeth had fused into a beak-like structure, but along the jawline, there were small tooth-like projections forming a filtering system, similar to the one found in today's baleen whales. Kynodus reached about 3 feet in length. It is believed that it swam close to the bottom of shallow waters and coastal areas. In its behavior, it somewhat resembled rays, feeding on carrion, fish, and various mollusks. Its limbs were better adapted for swimming than walking, so these creatures rarely ventured onto land. However, most members of this superorder shared very little in common with turtles. At the beginning of the 20th century, researcher David Watson proposed that the ancestors of turtles might have been the Eunotosaurus, diapsids from the latter half of the Permian period, first described in the late 19th century. Watson believed that catalosaurs could represent a transitional form between Eunotosaurus and turtles. However, despite the well-studied fossil remains of Eunotosaurus available to scientists, there is still insufficient evidence to fully support this theory. Eunotosaurus lived in what is now South Africa roughly 260 million years ago. Their unusually broad bodies, composed of 9 pairs of expanded ribs, hint at a possible relationship to turtles. Yet, well-preserved skulls of this creature have not been found, making it impossible to compare their cranial structure with that of turtles. Since the classification of these reptiles relies heavily on skull features, this gap leaves their exact relationship uncertain. Although scientists have yet to conclusively determine which ancient species first decided that survival required encasing itself in a solid shell, the ancestors of turtles clearly succeeded at this task. Hundreds of millions of years later, turtles still rely on this armor, and perhaps, with its help, they will outlast not only the dinosaurs, but even us. We extend our sincere thanks to all viewers who watch our videos to the very end. For those intrigued by this topic, we invite you to explore the content of our previous episodes.